Hello, everybody. My name is Dovydas, and I'd like to welcome you today to our meetup called Clean Code: Striving for Excellence. I'm very happy to have yet another meetup, and all of these, it's always very exciting to introduce new concepts or to remind of things which you may already know in the Tribe of AI and Lithuanian Artificial Intelligence Association communities. So let me quickly introduce myself. As I mentioned, my name is Dovydas, and I'm the president of the Artificial Intelligence Association of Lithuania. I'm also machine learning team lead at Vinted, founder of Tribe of AI, and Turing College data science lead. As you see, I do quite a bit of things and work with artificial intelligence, but it's all in this one field. Let me quickly introduce you to the plan. So the plan today is to start with the community updates. Then we'll have Clean Code: Striving for Excellence presentation by Kevin. And finally, we'll have Balancing Code Quality and Delivery Speed panel discussion with our guests today, Povilas, Jogundas, and Jonas. I will introduce them in a bit more details after when we start the discussion. By the way, if you have any questions regarding the presentation or discussion, just write them in the YouTube comments, and I'll be the moderator today, and I'll forward them to our guests. So let me start with the community updates, and yeah, the first thing is, I guess, let's celebrate that today is the 6th joint meetup between Artificial Intelligence Association of Lithuania and the Tribe of AI. These things happen so fast, and it seemed just a few days ago we decided to do joint meetups, and today we have already our 6th meetup. So that means half a year has already passed. One more thing which I'd like to celebrate is that our members page is finally live. It was actually live for maybe 2 months already, but I know that not everybody knows about it. So please go check it out. We have all our association members publicly published on our main website. Then we have a few more new things published on our website. So that's our OKRs and our projects. So they are also publicly available now on our website. So with all of these fun things happening in Tribe of AI, I'd like to invite you to become a member, and if you want to do that, just follow this link, and you can do that. By the way, all of the links will be published later, and if you go to the place where you have found the link to this meetup, you'll find that all of these links, you don't have to go and find the presentation. You'll find the links directly there. One update regarding the Tribe of AI is that we are looking for mentors for the AI Academy. So my vision was always to have it a little bit more distributed, and in a way that more people could be mentors and could help the next generation of data scientists and machine learning engineers to enter the workforce. And you can do that if you have machine learning skills. Finally, we will have new teams for the AI Academy, and what this means is we will start the new B class later this month, and we'll start a new F class probably later, probably next month. So lots of exciting new things are going to happen. By the way, give me a second. I'd like to invite Kevin So I see he has a little bit of trouble logging in. So give me a second to help him out. So meanwhile, while we are waiting, I'd like to maybe give, instead of introducing our panel discussion members, I would like to give them a chance to introduce themselves. And let's first, Jogundas, could you introduce what you do very shortly?
Hi, I hope everybody can hear me. So my name is Jogundas. I used to be the Chief Operating Officer for Occipit, which is a medical imaging computer vision startup. Currently, I have moved on to other projects, but my perspective will mostly be based on my experience there.
Right. Jonas, could you introduce yourself?
Everyone. Yeah, so I'm Jonas. Hello. I'm the CTO at Occipit, and Jogundas already introduced Occipit, I guess. So I'll just introduce it from a slightly different angle. What we do basically is help radiologists by automating some of their work, and we use AI to do it. So I'm the CTO there, and I'm in charge of the developer team.
Right. Povilas?
Hello, everybody. My name is Povilas. I'm a scientist at neurotechnology, and my areas of research is adaptive robotics and electroencephalography.
Right. Yeah. Thank you for introducing yourselves. I'm really grateful for you agreeing to be here today, and like it would be really interesting to hear your perspective on how you do on how you do this balancing between iteration speed and between code quality while doing machine learning projects. So let me give the floor to Kevin. He's already here. And Kevin, could you say hi, and could you try to start your screen share?
Yes, hello everybody. Let me start my screen share.
I think it's already working.
Yes. One moment. Okay. Can everybody see everything? Can we see my screen?
Yes, it's all good.
Okay. So, so I start. Hello, everybody. I'm kind of not used to presenting in this way. I come from a teaching background where I taught live, so teaching in this way is not that familiar to me. So I hope you will bear with me while I try this new format. Dovydas, do they have the reference sheet to be downloaded or not yet?
Yeah, let me post that to the comments right now. So okay. Just give me a second and I'll do that for you.
So while you're doing that, I will continue. So I don't know where everybody is. Some people may be at work, some people may be driving or at home with their kids. This talk will be about 30 minutes, and for it to be really effective, and my purpose is for it to be very effective for you, if you can give this 30 minutes in a focused manner, and a couple of things you can do to help this focus is if you can get a piece of paper, not your screen, but an actual paper and a pen, it would really help if while you're listening and looking at the screen, you're actually writing and making some notes or writing some questions as well. That would really help your focus, and it would help for this talk to be really, really good for you. The other thing that I want to say is if you have any questions, I don't know if there's a structure for that, for us to be able to answer them. Somehow, if there is a way, send it, and if I can answer it, and if not, I'm sure that Dovydas or one of the other panelists can answer.
Yeah, so regarding the questions, you can always ask your questions in the YouTube comments. So just ask them there, and I'll forward them to Kevin when appropriate.
The last couple of things before we get started is that this is going to be a highlights talk. The book that I'm going to be talking about, Clean Code, is about 500 pages. Of course, in a 30-minute talk, we cannot get to that detail. And it's not the purpose of this talk at all. The purpose is more of a highlights, kind of like you go to a new city and somebody takes you on a tour and they just show you the major highlights of the city. They don't go through every little street to show you every corner of the city. So kind of look at it in that way. And the last thing is about, I'm a student, so some of the things that I may say may be incorrect or you may disagree with based on your experience. I would just ask you not to tune out and say, well, this doesn't apply to me, and then the rest of the talk you would not listen to. Stay with the talk. I promise you that there would be at least one and hopefully more than one thing that you will get from that you can use right away. I will also promise that you will get the other part of this talk, which is the striving for excellence part. I actually think that that part is the most important part of this talk, because of this ability to strive for excellence, you would get the information you need and the tools that you need in whatever way possible. So I would say that even that part is more important, and you will for sure get something there. Besides the promise that you will get something immediately, and the technical things that I will talk about in this talk, I also make another promise to you that you will get this connection between what is excellent and being a professional. So this talk is kind of about this striving for excellence and being a professional in our field of software development. So with that, I will start with one of the quotes from the book, and I will use a lot of quotes from the book so that the learning is direct. And I will read also the quotes that I will present to you, because by listening, looking, and writing, you're actually increasing your amount of interaction with the material, and your learning will increase. So I'm not able to see my screen totally well because part of it is covered by the other screens of Zoom. Is there a way to disconnect that?
Like
I see.
hard to tell.
I got it. Okay. So So let's start with this quote from the book, and it might seem kind of discouraging, but it's not. Learning to write clean code is hard work. You must sweat over it, you must practice it, and watch yourself fail. You must also watch others fail. So right here, we understand that this is not going to be an easy process. It's kind of like practicing anything. You need to really fail a lot of times and work hard in order to achieve this level of expertise. And this is what the book Clean Code promises, that if you do the practice, you will be able to achieve this level of proficiency in writing good code. And we haven't gotten to what is actually clean code. That's coming next. Before we get to actually that part, I want to ask a few questions and then connect it to everything towards the end. You may want to write down the answers to this. You may want to type it and send it in whatever way. Let's do an interaction right now. The first question is, what does it mean to be a professional? Think about that for a few seconds. What does it mean to be a professional? You may want to jot down some ideas. Do you know a professional? Do you know somebody who's a professional? And that person could be a plumber. It could be the person who cuts your hair. It could be your doctor. Anybody can be a professional. Think about if you can identify somebody who's a professional by whatever definition you have right now. And the third question is, are you a professional? In whatever field you are, if it's software development or not, are you a professional? If you answer yes to yourself, answer why you believe that. And if you answer no, answer why you believe that. I'll give you a few seconds for that as well. Okay, so let's get to another big quote from the book that I really think encapsulates everything. When I read this, I thought, wow, I really get this. And I'll read it to you, see if it has the same effect on you. Getting software to work and making software clean are two different activities, actually two very different activities. So our job as developers is actually two jobs. We have to get the software to work for sure, but we also have to make the software clean. And we will see what that means very soon. But these two are two different jobs. So I'm going to break the remainder of this talk into three parts. I called the first part the what, the second part the why, and the third part the how. The what has to do with what is clean code, and then why should we write clean code? Why is that so important? And the third part is the technical part. How do we write clean code? And in the technical part, there are many, many things that I have skipped, but I've tried to find the most essential or the most basic ideas for this talk. So let's begin with the what. What is clean code? Now, I love analogies. Whenever I taught before, I used analogies a lot. It's a very, very effective way of teaching because it allows people to connect ideas in their mind. So I'm using the analogy of writing English text to writing code. The book on the left is called The Elements of Style. It was written, first published in 1918, about 100 years ago, or over 100 years ago now. And this book has been read or has been recommended for every journalist to read, every writer to read, every report writer to read, anybody who has any job that involves writing. This has either been recommended to them, for most of them, or they have read it. And it's a very old book that is still in publication. The first publication was just 50 pages long. Later it became longer, but in 50 pages, he encapsulated what it is to make your writing beautiful. And clean code is actually doing the same thing, but with code. How do you make your code beautiful? The right picture is a Harry Potter book that I haven't read myself, but I've heard that many people like it, and the writer is a very talented writer. So I kind of put these two together for you to have a concept of writing, what it is to write clean code, and what it would be like, what is the result of it, that great production, that great project that you will complete, that when somebody looks at it, they will say, wow, it's beautiful. So here is the what. What is clean code? Clean code is code that is read like a well-written prose. Prose is a piece of writing. Clean code is code that is read like a well-written prose, like a well-written story. It exhibits attention to detail. This part is very, very important. It exhibits close attention to detail, which means that for anything to be amazingly good, you have to pay attention to detail. And this is what the book promises you, that if you follow the ideas of this book, your result will be something that would look like very well-written prose, a very beautifully written book, a very beautifully written story. So now that we know what is clean code, which is beautiful code that somebody would look at it and would know that the person who wrote it really cared. So, but why do we write? Why should we write clean code? What is the reason? Why shouldn't we just write code that works? Okay, code works, then forget it. It's finished. My job is done. Well, it's not done. And the reason that it's not done, another analogy, imagine that your car, if you have a car, in this, or if you've ever had a car, if you know of a car, of course, cars are everywhere. The span of the life of a car, most of the time, it is not with the designer. It is with the people who have to work on the car to fix it, to maintain it, to replace parts, to do something with the car. So it's the same exact thing with software. In software, 80% or more of what we do is maintenance. Now, you see that wherever I put quotations, that's something that is from the book, is not from me, but I don't every time say that it's from the book. So just remember that quotations means that it's from the book, except for one part that it was for me, and I'll come to that towards the end. In software, 80% or more of what we do is maintenance. So your code is looked at, read, studied, changed, added to, taken things away from all the time. He said somewhere in the book that the ratio may be as much as 10-1, meaning that 10 times more of maintaining the code than writing the code. The amount of time that's spent maintaining the code is about 10 times more than that original writing of the code. So why should we write clean code? Because somebody has to read it. Somebody has to work with it. years down the line, months down the line, somebody has to look at your code and understand it. So you have to write it so beautifully that somebody else will get it easily. So now that we know why clean code, we're getting to some of the technical aspects of this talk. And this is the how part. How do we write clean code? Now, as I said, the book is around 500 pages with many, many different ideas. I picked just some of them for this talk. So for this talk, I believe that I picked about 4 topics, 4 major topics, and we'll go through them right now. I picked one for writing comments, a big rule for writing comments. 2 rules about functions and 2 rules about classes. 3 rules for naming variables, functions, and classes. How do we choose good names? And I also picked about 5 rules of formatting. And again, there are many more rules, but I picked some of them, especially with formatting. There were like a bunch of them. I just picked a few for this talk. So we will go through these 4 topics right now. Again, a quote from the book, and this is the only thing that I'm going to say about comments. When you find yourself in a position where you need to write a comment, think it through and see whether there isn't some way to express yourself in code. I'll read this again. It's very important. When you find yourself in a position where you need to write a comment, think it through and see whether there isn't some way to express yourself in code. So if you find that you have to explain your code, write it better. Instead of writing a comment to explain it, write it better. And the little bit of time, maybe a few minutes, maybe a few seconds that it would take you to write your code better will have dividends down the line over and over again when other people try to read your code. Some of the changes you could make are maybe very simple. Making a big function smaller, which we will get to. Choosing better names, which we will get to. Formatting, which we will get to. So you have to look back at your code and think, what can I do to make the code itself better? Rules about functions. 2 very important rules. First of all, a function should only have one job, only one job. If your function has more than one job, you need to break it down. And why is that? Because that's how your code will be easily read. Small functions, each one doing a job. So somebody who will look at your code knows exactly, this is the job of this function, this function, this function, this function. The way he would say it is this. Again, quotes from the book. The first rule of functions is that they should be small. The second rule of functions is that they should be smaller than that. Functions should do one thing. They should do it well. And the last sentence, the most important sentence, they should do it only. Write small functions with one job. If you see that you cannot find a good name for your function, or if you see that your function is big, think about maybe it can be broken down into smaller functions. With classes, it's about the same 2 rules. The first rule of classes is that they should be small. The second rule of classes is that they should be smaller than that. So again, with functions, classes should have one responsibility. One thing that they are defining and within the class, they might be changing, and that's it. If you have a hard time figuring out a name for what is this class defining, maybe you want to see if your class actually has more than one object that it is working with, and you can break it down. Now let's get to names. Look how beautifully he said it in this quote. Choosing good names takes time, but saves more than it takes. Down the line, over and over, somebody would read the name and would understand it better if you chose a very good name. So let's see how we do that. First, for variable names. By the way, the purpose of names, variable, function, classes, whatever, is really to explain what it is that you're naming. So from his point of view, and now from my point of view, the name can be as long as it can be. What matters is not that the name is short. What matters is that the name explains exactly what it is explaining. So let's look at these three examples. Let's look at number one. This is the name of a variable, elapsed time in days. Now imagine that this name was X. Well, who would know what is X? So you would have to write a comment to explain X. Why not write the variable name clearly? Now imagine that this name was just elapsed time. That's still not clear. Elapsed time in days makes it clear. Another example, seconds since creation. Very clear, there's a unit of time and it says when it begins. And the third example is very easy to see, number of tasks. Very clear when you read the name of that variable. And just by doing that, just by making your variable names clear, you're adding a lot of clarity and understanding to your code without comments. Function names. First of all, function names should be in a verb format. Functions do something. So their name has to be a verb because verbs in English do something. Verbs are, here are some examples, print, email, display. Email not in the noun sense of email, but emailing something. So email stock message, that's a verb, that's an action. So you give function names action words, verb words. On the other token, about class names, you want them to be nouns because classes define an object, define something, and that definition is not an action. So they have to be in the form of a noun. Here are some examples: customer, account, vehicle, and so on. Now, I took this one also from the book. I really like this quote. It's about naming. You should name a variable, and I would say function, classes, anything. You should name anything in your code using the same care. Now look how carefully he worded this. The same care with which you name your firstborn child. This is how important it is. And again, why is it important? Because somebody has to read your code. And if you write it clearly, that person will have an easier time understanding it. So we are close to the end of our talk, and I'm going to finish this part of the technical part with some rules of formatting your code. Now, when I will talk about the rules of formatting, I will use another analogy of writing or reading articles or news articles. How are they written? There is a very close correspondence with how your code should be written. Let's look at the first one. use white space or blank lines, sorry, to separate different aspects of your code. So just like when you read a book, an article, an essay, there are paragraphs, and in between paragraphs, there's some white space. That's how you know that there's a separation. You have to do the same thing when you're going from one thing to the other. You need to separate them so that the person who reads your code understands that this section finished, this part finished, and another part is starting. Just like also with a news article, you want to put the most important thing first. So functions are basically how we write code. It's the basic parts of our programs. So you want to put the most important functions towards the top of your code, so that just like when you read a story, or maybe not a story, but let's say a news article, the first paragraph really explains everything. And the rest of the paragraphs are details related to that first paragraph. The same way with functions, put the most important one first. And just like with news articles, code that is similar, or that kind of is related, not similar, but related to other piece of code should come close to, so that a person who is reading knows that there's a relationship between these two sections of code. So you put them vertically close to each other. And we're looking still with the same idea of a news article and closeness of things that are related. When you declare a variable, make it as close to where it is used. So the person doesn't have to go all the way to the top of your code to figure out what it is at the bottom of your code that you're now working with. Your variable, if it's near where it is used, then it's very easy to follow and understand your code. And the last one, again, there are many other format ideas. These are just 5 of what I consider to be the most important. If one function calls the other, they should be close. We kind of saw that in the items above, related things being close. Now here's the important part. The caller should be above the callee. The function that is calling another function should come first. So that function, the important function that is calling the, let's say, less important functions, but maybe they're not less important. Again, just the caller is going to call other functions. So it has to come first so that we know that it is calling other functions and we can find them right below that function. If this was really my classroom, I would keep saying, well, are there any questions? Are there any questions? But of course I cannot do that. So I want to come back. This is, we're close to the end of our talk. I want to come back to this idea of excellence, because the title was Striving for Excellence. You may have an idea now of why the title was Striving for Excellence, but let's go through it and identify it in this way. Again, the use of analogies. My wife tells me that I always use cars for analogies, so here are some more cards. Look at these 2 pictures. I picked them from the internet. I don't know if you like Mercedes-Benz, but let's say that you do, and let's say that you think that it's an excellent car. And I don't know what this other car is, and let's say that this car we consider not excellent. When you look at these 2 cars, look at the big picture. They both have 4 wheels. They both have windows and doors and seats and trunk and lights and brakes and gas pedal and steering wheel. They both have all the major things. They both run, but we call one excellent and not the other. Why is that? Why is that? Think about that for a second. I don't know if you will agree with me on this, but I would say that what makes the left car excellent is all the details of that car, not all the big picture of the car, but all the details. Are the seats more comfortable? Does the steering wheel turn easier? Are the lights brighter? It's not the big picture of things. It's the combination of many details. So why am I saying this? Why am I bringing up this idea of details? Remember that I want to talk about excellence. So I would say that it is all in the details, that to write clean code, and the car was an analogy, you need to pay attention to the details. And somebody who pays attention to the details really can make their code a lot better than somebody who just kind of comes and makes sure that the code works and that's it. It's kind of like you ask for a plumber to come to your house and fix something, and they fix it. The pipe doesn't leak anymore, but you go and you look and the tape is messily put on the pipes. And if there was something that they had to fix on the tiles, it's a messy job. You would not say that that is excellent work, although there's no more leak. So I want to go to this quote right now, also from the book. Writing clean code is what you must do in order to call yourself a professional. I'll read it again. Writing clean code is what you must do in order to call yourself a professional. It doesn't say making your code work. That's the big picture. If you don't know how to do that, then forget it. You don't have a job. It says writing clean code, that second part. Remember that at the beginning, it's two different jobs, making your code work and making it clean. This is about the second part. If you don't do the second part, you're not considered a professional. And then who is a professional? Now, this is my quote. This is what I wrote. Maybe you agree with it and maybe not, but this is who I consider would be a professional. The mark of a professional is attention to detail and striving for excellence. Thank you very much.
Thank you, Kevin. That was really interesting. I'm like really impressed with the delivery and how much of the details you have managed to capture in your presentation. As you mentioned, this is a pretty, I would say, famous book, and it's a large one. So I mean, great summary, and I can say the same things about your learning materials, which I have uploaded to the YouTube chat.
Thank you.
All right, so let's proceed to the second stage. The second stage is our, like the five of us are going to discuss the code quality, and one interesting aspect of the code quality, especially in machine learning, is balancing it with the delivery speed. So a short introduction, at least that's what happened. What's I guess happening in Vinted. Our current dilemma is we have quite a few. We do things very iteratively, and we have quite a few of these like maybe opportunities to write code in a like very thoughtful way, spending quite a bit of time, as you mentioned, in variable naming, in refactoring, etc. or we can iterate fast and maybe figure out in the end that we don't need any of this code because we train the model doesn't get the accuracy which we need. So we need to go back and talk with the product people to discover maybe we can approach the problem. We can tackle the problem in a different way. So I would be very interested to hear today how you're dealing with these dilemmas in your companies, and maybe answer the questions how we deal with that in Vinted. So far, we don't have any questions in the YouTube comments, but I invite everybody to ask questions there. So the discussion is going to be much more interesting if we get some questions from the audience. And maybe we can just start with you answering a little bit with the context, like what problems you have in your companies, and how do you what's your strategy in dealing with them? So maybe we can start with Jonas.
Yeah, so like I mentioned in my introduction, I work at Occipit, and I guess we're like a straight up applying research ideas to production sort of company. So we definitely run into the sort of problems that you mentioned. And I'd like to actually push back a little bit on what Kevin said about professionalism, because the way Kevin defined professionalism is mostly for, straight up software developers, software engineers. So it is also my opinion that you have to write clean code if you want to be a good software engineer. However, not everyone who writes code is a software engineer, in my opinion. For example, data scientists have their skill sets distributed a bit differently, and you can't expect them to write perfectly clean code because it's a completely separate skill, a skill that takes both time and effort to master, and you might not have time for like learning everything, right? So the way it's kind of positioned in Occipit is that we have two teams. One of them are data scientists and the other is developers. And the only really way to resolve these issues, I think, is through dialogue. There's just no other, nothing else that you can really do. The research team always has to be constantly talking to the developers and like presenting their ideas, and developers can provide some feedback on how to make the prototypes work better. And sometimes you just have to agree that what the research team is working on is just a prototype. It has to be thrown away and rewritten from scratch as soon as it's proven to work. So I kind of meandered here a bit, but I hope I've answered at least a little bit of the question.
I think it's like the idea here is to set the stage for the future discussion. So interesting insights. So maybe Jonas, maybe you can continue.
Yeah, thanks. So first of all, I'd like to thank Kevin for a very entertaining presentation. I certainly appreciated that, and it was really fun to listen. And I would also like to expand on what Jonas said. So indeed, the book presumably talks mostly about a software developer as a professional, but that is kind of narrow in the sense that software developers function in a variety of different organizations, and people of very diverse backgrounds sometimes take up the tools of a software developer. So it's as in other occupations, it is extremely important to find a balance between the beauty of the code, the readability of the code, and other factors. And what I have in mind here is that these different organizations can be universities, where a student in some non-computer science subject would have to use coding as a tool to accomplish certain tasks, which usually results in a code that is kind of run only once and then discarded. Nobody has to maintain it. And then on the other extreme, you have organizations like NASA who write code for that has to be maintained for decades. And then all this ideology and learning about cleaning up the code, documenting it properly, being extremely explicit in communicating your intent, both in the code base and in the documentation, comes into play. So having said that, I'd like to just summarize that in my mind, it's extremely important to strive for professionalism if that's what you're focused on. And while doing so, it's also important to maintain balance with the other parts of your organization or your life.
Right. Povilas?
First, thank you, Kevin, for your talk. And for example, in our company, in neurotechnology, the development process goes through two kind of workers. First, algorithm engineers, and the second ones are software developers. So algorithm engineers develop some algorithm, and then their output is passed to developers, and then developers they make software development kits based on those algorithms. And speaking about algorithm engineers, at some extent, I would agree that code standardization and cleanliness is important, especially when more than one person works on some project. So, but in our company, actually, we take the model that algorithm engineers can use any tools they want to use, and probably only final version of algorithms should be like more standardized. So that's my comment.
All right, I guess it's really interesting. I maybe would like to ask Paulus to follow up immediately. You said the final version should be productionized. So how do you can you elaborate a little bit on the process? So how do you know if that's the final version when you make this call to refactor the code?
Probably the criterion is time when we plan to do release, when some, not maybe just time, but results are maybe even more important. If we make, like, for example, better face recognition algorithm than we have than we had before, and we decide to release it. So the iteration goes from algorithms to software developers.
All right, it's really interesting. I'd like to invite right now everybody to participate in the discussion. I know we are all we are not in the same room, but let's imagine we are in the same room. I really believe that everybody's here like, oh, they want to add something. So please go ahead, and if you have a comment, suggest there is this neat function to do a reaction if you agree, or to just jump in and talk if you want to provide a counter example, or if you want to challenge what was said before. So for example, I have a little bit of a challenge that Kevin actually said. So actually, for what's in the clean code book, Kevin said that attention to detail is what the professionals do, and if you are a professional, you should do attention to detail. You should have attention to detail as an important skill in your skill set. So I think that this covers what we do in the machine learning world, even the data scientists or machine learning engineers. If you spend if you pay attention to the important details in what you do, it can still be considered that you are a professional. It just maybe we don't name the variables with as much care as it was suggested in the book. But I guess it's up to us as professionals then to decide where should our attention go, and it's sometimes it's just form. rather than function. Sometimes it's like we should really be able to distinguish between what's important and what's just good technique. And maybe Kevin, maybe like after hearing the comments, maybe you have something to add to the discussion.
For every rule there are exceptions. So every rule that anybody says in any circumstance, there are always exceptions to that. And my perspective right now comes from not the perspective of 20 years of experience. So I cannot say that I know all the exceptions, but I know that they exist. So yes, what you said and what everybody else said is absolutely correct. There are times when you want to do something and it could be done quickly. You don't need it anymore, so you don't pay attention to writing every variable correctly and paying attention to all these little details that he's speaking about. But there are circumstances when you do.
I'd like to ask the next question from the guys from Occipit. So can you elaborate a little bit about your code life cycle? Like how do you start when you're developing new features? How do you start the code? I mean, how do you go with through the iterations? And at which point do you decide to refactor?
So if I can start with that, maybe I will say a couple of softer things, and then Jonas can take it up and expand with a more development related comments. So Occipit is a medical device manufacturer, which means that our end product is actually very strictly regulated, and there is a process where our releases have to be kind of approved from a more regulatory point of view as well, which is not the case in most other software companies. So that kind of makes our case slightly exceptional, perhaps. Now, we have to balance this, or at the very beginning of the existence of the company, we had to balance this with being a startup, which means not knowing exactly what product is required by our customers. So this is a kind of interesting tension, which drove a lot of decisions both on the business side, but also in the data science workflow, as well as in the software development part. Now, when it comes to actual practices in the development team, I guess Jonas can add much more color to that than I.
Well, it really depends on what level of granularity are we talking. Like I mentioned before, I think we have two separate teams for development and for research. And if we're not talking about just like client-facing features that are just the work of developers, but rather AI stuff, that's the work of both teams, because that's the interesting part. So I'll just comment on that part, I guess. So the teams are quite separate because both teams have their separate iteration cycles, where the data science teams iterates on their idea and can write code whichever way they like. And the developer team also iterates on the product and does stuff. But like I mentioned, the communication between these two teams is like the most important thing to make this work. Because as soon as the research team starts doing something, they have to tell the developers that, okay, we're doing this cool thing. Look at it. It's going to do this or that. And the management expects that it's going to be released sometime in the future. And then that both teams can talk and agree that, for example, this thing can just be put into production pretty easily. Let's just subject it to the developer code review and we can be done. Or maybe this thing is a pure prototype and it will need to be completely rewritten for it to be put into production. So I'm not being super concrete here because the key is communication, and communication works best when it's a little bit informal.
Right, really. Maybe you can give us examples of like a story about where you did where the communication, where you used like this approach, and like the communication between the development and the research team was really critical to achieving the business goal in the end.
Right. Well, I can probably give a, not going too much into specifics, but give you some details on something we're working on right now, where during dialogue between the research team and the developers, we kind of saw that what the research team had in mind was kind of this huge thing that was going to take like many man-months of development to do properly. So what we're doing is basically just isolating it. It's in a way everyone agreed that it will need to be rewritten from scratch when it actually goes into production. And while it's isolated, the research team can actually work on it as much as they want and kind of not exactly ship the thing, but demo the thing to anyone they want to. But their code still goes through the general code review that everyone does, kind of keeping that quality sort of at some sort of baseline, but not really being too harsh on it, just to speed up the development time. And this agreement was really, well, like I said, just the communication part was the most important thing, where we figured out what sort of life cycle should apply to this specific thing.
All right, it's really interesting. I'd like to share since the same question, and it's a little bit weird for me to answer my own question, but since everybody else has answered it, I'll tell you about how we do things in Vinted. I guess we have maybe a little bit of a more formalized process already. What this means is we usually, when we start the project, we started with at least 4 stages already planned. So the stages which we use is the initialization stage, POC stage, MVP stage, and V1 stage. And recently we decided to use fewer abbreviations, so I'm going to explain what each of the stage means. Actually, they are all very abbreviated or even acronyms. So the initialization stage, or the init stage, is when we gather the business requirements and agree on the initial, maybe one or multiple ways to approaching the problem. So this is where we work with machine learning engineers, work with business people. I'm going to say machine learning engineers or data scientists pretty much interchangeably, because in our company we mostly things can be tackled by either of these professions. So machine learning engineers approach or like communicate with product owners to decide what would bring business value, and at the same time what would be valuable, what would be, I guess, doable from the technical side of you. So if you have let's say a problem to classify, let's use some example which we don't do. Let's say we want to classify between the clothes which you would wear on your upper half of the body versus lower half. So shorts, pants, and shoes go in one bucket, and sweaters and t-shirts go in the other bucket. So let's say we make this useless classifier for some reason. And we have to agree. First of all, we meet with people from business side of the company, and we discuss. So why are we doing this thing? How would the success look like? What are the objectives of the project? And maybe we decide initially either go from the point of view that these ideas would not work, or these approaches would not work, and try to eliminate a lot of them quite quickly. So can we just ignore shoes altogether because they look sometimes like gloves and they're small, and maybe that would be pretty much difficult technically. And then the product people say like, no, we cannot do that. It's super important that shoes and gloves would be correctly separated. And when we iterate and either have this white list of possible solutions, or we have this black list of solutions which we will not try because that wouldn't work, and that would like miss the whole point of the project. So once we have this initial investigation out of the way, we try to create a proof of concept, so the POC stage, proof of concept, as fast as possible. So no code quality. This code is a throwaway code. Most of the time, the only criteria here is speed to prove that we can solve this problem. A lot of it, like we had cases, I wanted to say a lot of the time, but actually not. Sometimes we encounter problems which look solvable, but then we discover that, yeah, this is not, like the labels are extremely noisy, or there is just not enough information in the data to do a proper machine learning model with the accuracy which we want to get. And this proof of concept stage allows us to very quickly eliminate the ideas, or very quickly eliminate the approaches of solving the problem which clearly do not work. So once we have this proof of concept done, and we can confidently say, yeah, there is like a very likely, it's very likely that we will be able to solve this problem from a technical point of view, we move to the next stage, which is MVP, or minimal viable product. There we try to do the first version of the project which can be used by actual users. And this is the stage where speed and quality kind of becomes and we try to ship as fast as possible again. And there's this famous saying that if you're not embarrassed by your MVP, you're doing it wrong. So we try to keep this in mind, and at the same time, we know that probably we will iterate on this MVP. So we do the large things correctly or properly, but the details can be quite messy. So the larger architecture, I mean the pipelines, the pre-processing, these things will live on, but we can, maybe if you're trying like 5 models, maybe we don't pay too much attention. And I mean, it's both from the code quality point of view and both from the what we are trying. So we limit our hyperparameter search quite a bit in this stage, just to ship it faster rather than do an exhaustive check of all possible values. So once that's done, we deploy it, we do an A/B test, and after getting the results, we, based on the findings from the minimal viable product stage, we try to do the first version, which is proper. So here, everything slides, the slider goes fully for the code quality part and for the maintainability part, because the first version, or version 1, which we are happy with, which will live for quite a bit of time, which will be reviewed much more than like writing time and reading time is like in the favor of reading time. So this is where we refactor our code quite a bit and prepare for it to be maintained for the long run. And by the way, I mentioned these 4 parts as a starting point. Usually we initially create a version 2 stage where we just dump all the good ideas which we feel, yeah, this would be cool to try in the future, but we are not going to do that right now, so that we don't forget them, so that when we decide that this project needs improvement, we are not starting from a blank page. We are starting from like what ideas we had in mind, where we are very actively immersed in this project previously. So this like very iterative approach with very clear sliding of code quality rather iteration speed is I guess one of the findings which we discovered working on like multiple machine learning projects with different product teams solving different production like this, trying to make different types of features.
So David, if I might ask you actually a question. So how does the progression work at the very final stages of the project? Does it mean that the code gets taken over by some professionals, some developers, or is it that you require your machine learning engineers and data scientists to write production quality code immediately?
Yeah, amazing question. So we don't do any handoffs. We try to be well-rounded ourselves and be able to write the code in a clean way, since clean code is the keyword for today. That said, we have the final pull request approved by the machine learning platform team. There the code is going to actually run. So if it's if the platform guys have some suggestions, we happily fix the code and integrate these suggestions into the solution. But maybe to elaborate a little bit more, the stage is usually done there's usually at least one machine learning engineer involved, so that they can put a little bit more engineering into this machine learning engineering and have a code in a better quality than than it would be possible if only scientists would work at that.
Yeah, Doris, but I guess when that code is only for internal use. And for example, in neurotechnology, we derive products for example, for different processors and so on. So in the end, there is more work completely for software developers. And because of that, we forward work from algorithms to software developers. Mm-hmm. One of the reasons, I mean.
All right. I am very curious to learn about, how you guys are doing that, because you all come from, I guess we cover a pretty wide spectrum today, from smaller startups such as Occipit to, I guess, quite old, very, very with the great heritage companies like Neurotechnology, who have been doing artificial intelligence probably the first in Lithuania, right? Povilas, you were the first, right?
Yes, we are oldest and largest. Yes, actually, we were doing research in AI starting from independence or even before, probably. Company emerged from academic field.
Yeah, so it's super interesting, and again, when Vinted is a company which represents a typical startup, or I guess a scale up right now, which is going through this AI transformation. There we try to infuse our product with pretty good, not pretty good, but with features which are useful for our end users, which are powered by machine learning models. So it's three different worlds, and I very dig with what Povilas is saying about having forwarding it to software developers to be finalized and prepared for integration with the users of your platform. And I'm really curious about Jonas Jogundas. I'm really curious about you're also doing a similar handoff, right? So maybe you can go a little bit more in the details, and this maybe regulation comes into play here. So you really have to have a code which, if code fails if a machine learning model fails at Vinted, we don't separate these gloves and shoes into different buckets. But if code fails in your field of work, it's the consequences, I guess, a little bit more important. So maybe you can elaborate on this as well.
So I'm gonna jump on this first, if that's all right with Jonas. This maybe also relates to one of the questions that has been asked in the comment section of YouTube, namely about the documentation of the experiments and how the information generated during the machine learning process is generally written down. So I think that this is a very active area where a lot of development is happening globally. And I also feel that this is not a completely solved problem yet, just because there are no best practices and people are doing this in a variety of different ways. Now, when it comes to Occipit, again, due to the field where we operate, we are quite constrained by historical regulations and norms. So, and again, the medical regulations are somewhat special. So, for example, our machine learning experiment might also involve something that is similar to a clinical trial, where you have to gather data of patients. In order to do that, you have to get certain permits. And once you have that data, you have to make sure that this is representative of the people that your product is going to be applied on. So that's, again, another kind of a constraint. And then all the documentation, both of the model and of the input data, of the labeling procedure, all of this stuff has to be written down in a way that is understandable by an external auditor. So that might be a person who does not have a programming or a data science background. That might be a medical professional. So this kind of puts some interesting aspects to the documentation process. And on the one hand, it's convenient because people have done this sort of thing for many years. So there are templates. And on the other hand, this historical baggage also hinders adaptation and adaption of new technologies and novel platforms. So there again is some interesting tension there, how to be compliant while not bogging down yourself with legacy technology and legacy processes. Yeah, so I guess I will hand it off to Jonas from here on.
Well, I guess Jonas actually presented the most complicated part of this, which is the regulatory part. And it has mostly to do with the research output of the company. So what researchers come up with, the algorithms have to make sure they fit like these regulations and everything, and that everyone agrees that they're okay to put into production. And afterwards, from the software development side, things are not really that special. You can use tools that you usually use everywhere else. You write tests to make sure there are no regressions, that the output always does match the regulations and what you agreed it should be. Well, in Occipit, we can't really do proper continuous delivery due to the regulatory part, but we try to approximate to do continuous delivery to like demo environments and stuff like that. So these are just like off-the-shelf developer tools that pretty much every company uses, and you can just pick and choose, apply them in these situations as well.
Right. So I guess we are a little bit over timing as is. It's a very interesting discussion, and maybe let's answer the final question from the audience. Like we have 3 questions right now, and I guess I'm going to maybe reformat the question a little bit and just take from Paulus. So if you have, I'm interested if you have any formal code standardization rules. And if you do, how do you enforce them in practice? So maybe we can all answer this question. Maybe we can start, Paulus, from you.
Yes. For example, when occasionally we worked on one project in a way that the same small team works first as algorithms, and then as when they have algorithm result, they switch to developers and push that algorithm to final product. So we used Git hooks, for example, scripts based on a style in C++ case, or based on autopap in Python case, which simply do not let to commit code which does not conform to required standards. And it was quite good experience, actually.
Right. Jonas?
Actually, what Pavel has mentioned is very familiar to me because I'd say it's this way even, that code standardization is kind of a waste of time on an individual level, because a programmer should not be worrying about this stuff. So where possible, it should be automated always. So for example, in Python, it's really trivial to automate. There are a load of auto formatters. We at Oxford use Black specifically, which is just always applied. Everyone applies it, and the code is standardized. Not everybody likes the way it's standardized, but that's always a problem when you pick and choose a style. And of course, there's always code reviews which can like enforce more higher level standardization things. But if you're just talking about like the syntax and stuff, it's just auto formatted. Don't bother with anything else.
It's pretty much identical for us as well. We also use Black. Doesn't really allow a lot of customization, so I guess the code looks identical. And I just want to add, I mean, the part about the pull request, this is, I guess, the cornerstone of how we ensure our code quality. Tools like we use type hinting, we use linting, we use like I guess multitude of tools which help with like these small things. But I guess the most important part is code reviews, and this is where we deal with the more fundamental, or I guess more important even types of things which no automated tool can right now discover. And one additional maybe advantage which Black auto formatter provides is it's very, once you get accustomed to the code, it's really easy to pick up like for new joiners, or even if you're reading a code from like 3 years ago, it's really easy to you know, understand where everything is. You don't have to like spend this additional mental effort into understanding the syntax. There you can immediately see the underlying concepts. So it was a pretty great discussion today. I wish we could extend it for a little bit longer, but we are overtiming as it is. And I really appreciate all of you being here. The biggest thanks, I guess, goes to Kevin for making this presentation, and for making it in such a, I guess, in such a high quality and in such a high attention to detail type of way. So thank you all. Thank you, Kevin. See you next time. It was great having you here. Bye bye, everybody.